Hello guys, this is the MEPtutor, and in today's video I'll be solving this problem. We have a cabin of a fully loaded elevator that has a mass of 1.2 tons. Let's try that. The bigger mass is 1.2 tons. The cabin must be filled to a height of uh, 54 meters in 3 minutes, 180 seconds. The counterbalance has a mass of only counterbalance 950 kilograms. So the engine of the elevator must help in balancing the cabin. So the question is, what is the average power of the attractive force of the motor acting upon the cabin through a tow rope? Let's draw a diagram. We start with the motor. Here is the motor, and let's draw the cabin. Here, cabin with the bigger mass, and here we have a counterbalance, a little bit smaller because it's light. So which forces are acting in this diagram? You know, there is a wave. We call that wave of the cabin, we can call it gravitational force. And there will be the force of the counterbalance. Let's call that F, force of the counterbalance. And finally, there will be a force of the engine, which is the one we are looking for, because we are looking for the power done by the engine. So we will need this. Let's write first the equations in the x-axis. The forces in the x-axis are equal to 0 because nothing is happening. But in the y-axis, there is movement. Mass times acceleration. But we're going to assume that the movement of the cabin in this exercise is constant. So we are going to assume the acceleration being equal to 0 because it makes sense and it's the way we can solve the problem basically. So the forces in the y-axis are the force of the engine plus the force of the counterbalance minus the gravitational force, the force of the wave. That's the correct term. This is equal to 0. We clear the variable we are looking for. This is negative. The force of the wave minus the force of the counterbalance. And what else we can do in this problem? We are looking for the power. The power is just the work done over time. That's the equation of the power. It's work per unit of time. So we're looking for the work done. And how do we find that? We know that the work done is the force times the distance it's being moved in the direction of force. In this case is the height. So let's substitute the values. The force is mass times gravity minus the smaller mass times gravity times the height. And we can do a common factor here. Mass, the bigger mass minus the smaller mass times gravity times the height. So we can substitute this in the equation of power. And the power is going to be equal to mass times gravity. No. Mass minus the smaller mass times gravity times the height over time. and we can substitute all the values here. So the power will be equal to the bigger mass, 1.2 tons minus 950 kilograms times the gravity, 9.8 meters per second squared, times the height, 54 meters, all over 180 seconds. And we put this on the calculator, and the power is going to be equal to 735.8 watts. And that's the solution of the problem.